We shall now solve some more problems to consolidate our concepts on ratio, proportional, variation from problem set 6. Question 1. If A is to B is equal to 7 is to 8 and B is to C is equal to 12 is to 7, then find A is to C in the simplest form. Solution. We write the first ratio as A upon B is equal to 7 upon 8. We write the second ratio as B upon C is equal to 12 upon 7, that is, B upon C is equal to 12 upon 7. Now to get A upon 7, we have to multiply A upon B by B upon C and get A upon C. So we take the first ratio and multiply it by second ratio. Therefore, A upon B into B upon C is equal to 7 upon 8 multiplied by 12 upon 7 is equal to 3 upon 2. Therefore, A upon C is equal to 3 upon 2. Therefore, A is to C is equal to 3 is to 2. Question 2. If 5m minus n is equal to m plus 2n, then find the value of 4m plus n is to 4m minus n. Solution. We first use the given equation to find the value of the ratio m is to n. The given equation is 5m minus n is equal to m plus 2n. Bringing like terms together, we get 5m minus m is equal to n plus 2n. Therefore, 4m is equal to 3n. Therefore, m upon n is equal to 3 upon 4. Since m upon n is 3 upon 4, we multiply the numerators of both the sides of equation by 4. We get 4m upon n is equal to 4 into 3 upon 4, which is equal to 4m upon n is equal to 12 upon 4. We now apply componendo and dividendo to get 4m plus n upon 4m minus n is equal to 12 plus 4 upon 12 minus 4 is equal to 16 upon 8 is equal to 2 upon 1. Therefore, we get 4m plus n upon 4m minus n is equal to 2 upon 1. That is, 4m plus n is to 4m minus n is equal to 2 is to 1. Question 3. Find all possible integers whose geometric mean is 16. Solution. Let the geometric mean be b and the integers be a and c. Hence, b square is equal to a into c. Therefore, 16 square is equal to a into c. That is, 256 is equal to a into c. The factors of 256, which when grouped in pair, give the product 256. Hence, the pairs of factors will be 1 into 256, 2 into 128, 4 into 64, 8 into 32, 16 into 16. Hence, the pairs of integers are 1 and 256, 2 and 128, 4 and 64, 8 and 32, 16 and 16. Question 4. The price of diamond varies directly as the square of its weight. The diamond having weight 10 decigrams costing rupees 4,000 broke into two pieces having weight 7 decigrams and 3 decigrams respectively. If both the pieces are sold separately, find whether the merchant will get profit or loss and how much. Solution. Let the price of diamond be denoted by P and weight by W. Price of diamond varies as square of its weight. Therefore, P is equal to kW square, where K is a constant. Now it is given that W is equal to 10, P is equal to 4000. By substituting the values, we get, therefore, 4000 is equal to K into 10 square. Therefore, K is equal to 4000 upon 100. Therefore, K is equal to 40. Therefore, the equation of variation is P is equal to 40W. Now, the 10 decigram diamond is broken into two pieces of 7 decigrams and 3 decigrams. When W is equal to 7, let us find the value of P. P is equal to 40 into 7 square. Therefore, P is equal to 40 into 49. Therefore, P is equal to 1960. Therefore, price of 7 decigram diamond is rupees 1960. When W is equal to 3, P is equal to 40 into 3 square. Therefore, P is equal to 40 into 9. Therefore, P is equal to 360. Therefore, price of 3 decigrams diamond is rupees 360. Therefore, total price of 2 pieces of diamond is equal to rupees 1960 plus rupees 360 is equal to rupees 2320. Let us find the loss. Therefore, loss is equal to cost price minus selling price is equal to 4000 minus 2320, which is equal to 1680. The merchant will suffer a loss of rupees 1680. Question 5. The volume of a gas is directly proportional to its absolute temperature and inversely proportional to pressure on it. When volume is 140 milliliters, the absolute temperature is 280 degrees K and the pressure on it is 15 millimeters. If the absolute temperature is 300 degrees K, the pressure on it is 20 millimeters. Find the difference in its volume. Solution. Let volume of gas be denoted by V, temperature be denoted by T, and pressure by P. The volume of a gas is directly proportional to its absolute temperature and inversely proportional to pressure on it. Therefore, V is equal to kT upon P, where K is constant. It is given that V is equal to 140, T is equal to 280, and P is equal to 15. Now, substituting the values, we get 140 is equal to 280 upon 15 into K. Therefore, K is equal to 140 into 15 upon 280. On simplifying, we get K is equal to 15 upon 2. Therefore, equation of variation is V is equal to 15T upon 2P into K. Let us mark this equation as 1. Now it is given that T is equal to 300 and P is equal to 2. Let us substitute these values in equation 1. V is equal to 15 upon 2 into 300 upon 20. V is equal to 225 upon 2. V is equal to 112.5. Therefore, new volume is equal to 112.5 milliliters. Difference in volume is equal to old volume minus new volume is equal to 140 minus 112.5 is equal to 27.5 milliliters. Therefore, difference in volume is 27.5 milliliters. Question 6. The cost of silver coin varies as its thickness and the square of its diameter. If the ratio of diameter of two coins is 4:3 and that of their costs is 4:1, then find the ratio of their thickness. Solution. Let the cost of silver coin be denoted by C, thickness be denoted by T, and diameter be denoted by D. Now it is given that the cost of silver coin varies as its thickness and the square of its diameter. C is equal to KTD square, where K is a constant. We have 2 coins, so let C1 and C2 be cost, D1 and D2 be diameters, and T1 and T2 be the thickness of 2 different coins. Now it is also given that ratio of the cost of the coins is 4:1. That is, C1 upon C2 is equal to 4/1. Therefore, C1 upon C2 is equal to KT1 D1 square upon KT2 D2 square. By cancelling K we get, therefore, C1 upon C2 is equal to T1 D1 square upon T2 D2 square. Now the ratio of diameter is 4:3, that is, D1 upon D2 is equal to 4/3. Therefore, substituting the value we get 4/1 is equal to T1 upon T2 into within bracket 4/3 the whole square. Therefore, 4/1 is equal to T1 upon T2 into 16/9. Therefore, T1 upon T2 is equal to 4/1 into 9/16. Therefore, the ratio of the thickness of 2 coins is 9:4. Question 7. 4 circles have areas in the ratios 3:7:11:19. 4 squares are formed whose diagonals are proportional to the radii of the above circles. Find the proportional of the areas of the squares so formed. Solution. Let the radii of 4 circles be R1, R2, R3, R4. Area of circle is directly proportional to square of radius. Area of 4 circles is equal to R1 square, R2 square, R3 square and R4 square. Therefore, 3:7:11:19 is equal to R1 square, R2 square, R3 square and R4 square. Let us mark it as statement 1. Now, area of square is directly proportional to diagonal of its side. Let diagonals of the 4 squares be D1, D2, D3, D4. The 4 squares have areas in ratio 3:7:11:19, but the diagonal of square are in proportion to radii of 4 circles. Therefore, D1 square is to D2 square is to D3 square is to D4 square is equal to R1 square, R2 square, R3 square and R4 square from statement 1. Hence we get D1 square is to D2 square is to D3 square is to D4 square is equal to 3:7:11:19. Therefore, the area of 4 squares are in ratio of 3:7:11:19.